Hi everyone, this is Raleigh Blue Tech, and in this presentation I'll be going over the TCP/IP versus OSI model. 1.1 of network fundamentals. Now that's taken from the Cisco's website under ICND1 topics if you wanted to follow along there. We'll start off with definition. The TCP/IP and OSI model is simply a way that different kinds of devices can talk to each other. So that means my cell phone talks to my laptop because they both understand the same network language, the same model, the same guide. This is an idea known as interoperability, when different devices can talk to each other because they follow a certain guide. The TCP/IP model was the first model that was created, and this was created in response to the internet, in response to a time when technologies were surprising the United States government, and they decided to create what's known as the ARPANET project, which is the Advanced Research Project Agency Network, basic foundations for the internet. And thus the TCP/IP model was born. And not long after that, the OSI model was also born. The OSI model is a practiced model today, especially amongst network engineers. It allows them to troubleshoot things, so when they talk, they can talk about the OSI model in layers. Sometimes it's a physical layer issue or a data link layer issue that they're troubleshooting. I'll go over that further in the next slide. I mentioned layers in troubleshooting because these models are best known for that. The TCP/IP has 4 layers, while the OSI has 7 layers. The reason why? Not because they're logically different. The TCP/IP combines some of the layers of the OSI model. So, for instance, the application of the TCP/IP is combined with the layers application, presentation, session of the OSI. The transport and network has a 1-to-1 correlation in the TCP/IP and the OSI model. However, the network in the OSI model is known as the internet of the TCP/IP. As we go further down, the data link layer and then the physical layer is again combined in the TCP/IP model as the network access layer. When it comes to troubleshooting, network engineers and the like will usually go for the OSI model because it allows for a more systematic approach when it comes to thinking about fixing the environment or figuring out what the issue is. So you want to start from the bottom to a top approach and eliminate all the issues that the layer you're on has before you go to the next layer up. Though troubleshooting is a bottom-top approach, when sending data, it's a top-bottom approach. The reason? A user first initiates information being sent through the network via the application layer. So a user could use Mozilla Firefox to send information to another end computer, and in order for that to happen, the information is encapsulated down these layers. And the reason why it's encapsulated is adjustments have to occur to the information that allows it to be sent through the traffic via the physical layer, which turns this information into electrical currents. When it's received by the end unit, the information does what's called de-encapsulation as it works its way up the OSI model now. So instead of going top to bottom, the information is sent from the bottom to a top approach, coming from the physical layer, electrical currents, and then it de-encapsulates it up to the data link, and then finally to the application layer, which allows the information to be received as intended by the sending unit. Now, it's important to think about the transport network, data link, and physical layer in this encapsulation process via their protocol data units. So in the physical layer, the information becomes bits. In data link layer, it's good to measure it by frames. Network layer, it's packets. Transport layer, it's the TCP segment or the UDP datagram. This last slide goes into further details of the different layers. As mentioned, the application layer is where the user can begin an initiation of how traffic flows through the network. For instance, a Mozilla Firefox browser. Then we have the presentation layer, which takes care of any syntax that the application layer might have, such as encryption or decryption. The next is session layer, and this manages communication between one network device to another network device, so it can open or close an agreement between devices that say, hey, let's communicate traffic. The transport layer is where the TCP UDP suite, and this controls how fast traffic is or how reliable it might be. The network layer is what does traffic routing. So if you've heard of IPv4, IPv6, public-private IP addresses, this is where it's categorized in. The data link layer moves data, and it's also done through addressing of the MAC or the burnt-in address of the physical device. Lastly, we have the physical layer, and this is responsible for traffic flow at an electronic or an electric rate. So that means bits are moved through electricity via the network appliances that exist there, such as routers and switches, computers, things that you can touch. Thanks for watching. This concludes the TCP/IP versus OSI model presentation. Please comment below with any acronyms or mnemonics that you can find about the OSI layer model. This is Raleigh Blue Tech, and don't forget to subscribe.